Welcome back. One final video here, and this is pertaining to the case where we run a chi-squared test and we end up rejecting the null hypothesis, and we say, and the only thing that we can say again is that there is evidence that one of the proportions is different, but we don't know which one, right? So that's where, when typically that's not enough in a statistical or in a scientific community. And so what you end up doing in practice is looking at those chi-squared components, each one of those observed minus expected squares over expected, and seeing, okay, what's going on here, like which ones are large, right? Because ideally the observed and expected should match, and so then if they match, that means that the numerator is 0. And so ideally we want all these chi-square components to be 0. But the question is, if we ended up rejecting the null, that means that some of them are not 0. So then that's where, when we do next steps and further analysis, we have kind of three questions we want to ask ourselves. So which outcomes differ the most from the hypothesized null? And then we can, in the same vein, it's, looking at observed counts and expected counts, which ones have more or less observed counts than what we expected, and are those more or less? And then thirdly, which chi-square components are largest. So each one of these is really saying the same thing in a different way. And so the question is, okay, how do we do this, right? How do we perform this analysis? And so we ended up rejecting the null when we were working with that eye color example. So let's take a look at that, okay? If you remember, here was the table that we constructed with that eye color example. Okay, so we had our observed, expected, da 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 da. So we have our chi-square components. And as we were going through, I indicated, okay, there's this 12 that is extremely large, right? And then down below too, with heterochromia, we said that one was large too. So what we would do as statisticians would say, okay, these were larger, these chi-square components were larger than what we expected, right? We want 0, so numbers close to 0 are okay. 2 is still kind of borderline. 2 is, you might want to look at, but really, if there's anything that's larger than, say, 5, definitely want to look at those. But nevertheless, so I could look at those if I wanted to. But then I would have to go back and say, okay, well, even though these chi-square components were going on, what was going on in the sample, right? So as I compare these two now, I see, okay, I got more observed than I expected. And in these next two cases, those were lower than expected. Actually, the next three cases were all lower than expected, right? So these, and apparently within these areas they were abnormal. So I would need to perhaps do further studies on, the population of people with blue eyes, amber eyes, gray eyes, and heterochromic eyes. Okay, so more investigation would follow. Another nice way to, rather than just looking at the pure numbers, I also like to make a chart. So I highlight the observed and expected and insert a bar chart. Okay, sometimes just a 2D chart will suffice, and again, I'm not going to pretty this up, but I would, include all the labels and include proper legends. And for now, we can just say that the blue is observed and the orange is expected. And so this version might be insightful, particularly when you have smaller sample sizes. But here, since I have such a large sample, it's really not too insightful. Another thing that is actually really interesting, and we'll see this more in chapter 22, is instead of looking at just the pure 2D version, you could change this and look at a 3D version. This is the one and only instance I would actually say a 3D version is insightful, because you can see more of the shape. So if you do kind of a layered 3D model here, and you can play with the formatting and everything, you can start to see, okay, where do the shapes of the distributions differ? Because that's ultimately what we're looking at. We're saying, if this is a good fit, right, the distributions should be nearly identical between observed and expected. And so the minute that we see some deviation from the expected counts, again, those would be here in orange, that's where we kind of a red flag should rise in our brain and say, okay, this is different than what we expect. What's going on? Let's investigate further. Okay, so just some ideas for you to consider as we think about scenarios where we do get the chi-square test saying, yes, we reject the null. There is something different going on here than what we expect.